So what is a scatter plot? That's the very first thing we need to make sure we have in our notes here. So what is a scatter plot? It is a way to display numerical. Here's one of those keywords there. We are talking numerical, so not categorical anymore, numbers. The data is given in numbers. Numerical, still bivariate. Numerical bivariate data to show. And this is one of the things we start with two-way tables categorical data because sometimes data is in categories and that's the best you could do, but I would argue that you don't get as much solid mathematical information out of categorical data as you can out of numerical data. When we take this information and we make them ordered pairs and we put them on a coordinate plane and we look at the scatter plot, we can get a lot more mathematics out of this and we can do a lot more with this statistics. So one more time, make sure you got this written down. What's a scatter plot? It is a way to display numerical bivariate data to show association between those two variables. Let's learn about what that vocab means, association, what are the different types of association and how scatter plots show that to us. So here is a scatter plot already created. And I would say, as I watch those videos of you guys showing me your notes, which it just warms my heart to see you guys working so hard on those things, you can draw this out exactly if you're drawing in your own notebook. If I'm sketching my own on a piece of paper, I don't usually draw every single grid line, but I will draw, say, the x-axis here. Remember, this is called the x-axis. Okay, we have the x-axis here and we have the y-axis here. So I might just sketch out an x-axis and I might sketch a y-axis and then draw a few of these key numbers and then just try to get the dots in a fairly accurate place. The thing that's really important with a scatter plot is just seeing what the general shape is doing. And you'll see what I mean by that as we go forward. Okay, so pause and sketch out however much of this you feel like you need to. The really important thing on this is, first of all, it tells me right here that this scatter plot has 11 dots. Okay, I counted them and there are 11 dots. What that means to me, and hopefully you saw this from your robot activity on Desmos, every single dot shows me one piece of data. And every single data point actually is showing me two things about that particular data. So things to always look at in a scatter plot: the title. So this right here is the title of this scatter plot. This overall scatter plot is talking to me about the beach visitors. Okay, then I'm going to look at the x-axis. So here's one variable down here. Bivariate means two variables. So one variable down there is telling me the average daily temperature. And then on the y-axis, I have the actual number of visitors. So the fact that this scatter plot has 11 dots tells me that this is showing me 11 different days. Those 11 dots are telling me the temperature and the number of visitors at whatever beach this is. I don't know what beach it is, but it's telling me the temperature and the number of visitors at this particular beach for 11 different days. So one day was 82 degrees and there was, I don't know, 80, 85, 90 visitors that day. You have to estimate sometimes. Another day was 84 degrees and there was about 225 visitors. So these 11 dots show me a combination of what the temperature was that day and how many visitors there were for 11 different days. Okay, so number 2 says pick one dot and tell me what that one particular dot means. So the one dot I'm going to pick, and you don't have to pick this one, but I just found one that looks pretty close to a corner. This is 84, this is 86, and I followed it up here. That one looks almost on a corner, so it felt easy to pick and work with. So I wrote the actual ordered pair, 86, 300. Okay, so 86, 300 is one particular ordered pair, one dot in this. And what does that particular dot mean? It means one of these 11 days was 86 degrees, and that 86 degree day had about 300 people at that beach. That's what that one dot means. And we could go through and we could give all the specific data for all 11 dots. But just to make sure you understand, each dot shows me what's happening on a different day, and each dot actually is bivariate. It gives me two variables of information, the temperature and the number of visitors. Now, here's this keyword here. Does there appear to be an association between daily temperature and number of visitors? This is what's really key here, is that I see a general overall trend in this, and I could even kind of draw it, and this will become more useful to us next week as we finish this up. But I see a general overall trend of this just kind of increasing upward. Kind of like a slope, as we learned about in all of our linear stuff. These dots, yeah, they're scattered, and no, they're not in an exact pattern, but in general, there is this general trend of this climbing upward. So does there appear to be an association? Well, looking at the shape of this graph and just thinking common sense about what makes sense here, yeah, there is an association. So here, down here, these are my X values, and these are my temperatures. So here's what I want to make sure you remember and understand. For the X-axis, we're getting, this direction is getting higher. Those values are getting higher. And for the Y-axis, this direction is what we call increasing or getting higher. And I notice as the temperature increases, as we move farther right on the coordinate plane, the number of visitors also increases. As I move to the right, I also move up on the Y-axis. So what that tells me is, yeah, there's an association. As the temperature goes up, as it gets warmer, more people go to the beach. That makes sense. As one goes up, so does the other one. And when I say as one, what am I talking about? Well, let's clarify, okay? Here's the next part of your notes. And this is really key, important vocabulary for scatter plots. This is really, really important right here. This is a huge part of your 8th grade course, just understanding that a scatter plot shows association. And then what does that mean? So you have 3 different options. You have positive association, and the beach example is an example of positive association. So here's what we're going to write down for positive association. As the X variable increase, as variable X increases, so does variable Y. In other words, they move together. As one goes up, the other one goes up, like temperature and beach visitors, okay? As one increases, so does the other one, okay? And we're gonna draw an example of that over here on this coordinate plane. We're just gonna remind ourselves that this is the X-axis, so that would be variable X. This is the Y-axis, so that would be variable Y. And it's a scatter plot. You can do as many dots as you want. You can make it as scattered as you want. But in general, what we're saying is, if I start with, say, a dot here, as my X's increase, my Y's also have to increase. So as I move to the right, I also, and you can have some kind of stacked on each other, but the general pattern here is you're going to see a general upward trend in your dots. And sometimes you'll have some that fall outside of things just a little bit, but in general, what you should see is positive association is exactly like positive slope. So as the X increases, so does the Y. You'll see this general left to right upward movement in your scatter plot. So positive association is just like positive slope. It's just scattered, okay? All right, so then when we're in class and then I ask students, okay, positive association is as one variable increases, the other variable also increases. And then I say, what do you think negative association is? And you know what people always say? They always say as one goes up, or as one goes down, the other goes down. That's what they want to tell me. So if positive is as one goes up, the other goes up, then negative is one goes down, the other goes down. Actually, that's the same thing as this right here. If they're moving up together, they would also be moving down together. Because if I come back this way, as this goes down, so does this. So please keep in mind that positive association is moving together, up and up, or down and down. So guess what my thumbs would have to be doing in order for this to be a negative association? They would have to be going in opposite directions. So if positive association is moving together, negative association is moving in opposite directions. So a negative association means that as one variable increases, as variable X increases, variable Y actually has to decrease. So as one goes up, the other goes down. They are moving in opposite directions. And watch what happens on our actual scatter plot if we do that. So let's sketch an example here. And again, if you're sketching this at home, don't draw all of these grid lines. You don't need all of that. Just draw the X-axis, draw the Y-axis, and give yourself some dots. Now, here's the thing. If X is supposed to go up while Y goes down, it probably doesn't make a lot of sense to start your dot right here because then you don't have anywhere to go down from. So what if I start here? Here's the thing that sometimes confuses students because they're like, wait, isn't that high on both variables? No, this is really low on my X's and really high on my Y's. You see that? So if I start up here, negative association says as the X increases or goes right, the Y is now supposed to decrease. So look, that is going to be sketched out something like this. It doesn't really matter where these dots are, but what matters is that you see a general downward trend. As X increases, the Y is actually, whoa, that went really far. The Y is actually decreasing, very much like a negative slope, right? So we already know a ton about slope from our 8th grade year. Positive association will show a positive general slope. As one variable increases, so does the other one. And negative association will show a general negative slope. And that means as one is going up, the other is going down. So positive association, negative association. And then there's, of course, one more option. Sometimes we compare two variables and we see no association at all. That certainly happened with some of our two-way tables with categorical data. It's definitely going to happen with some numerical data too. You'll see some examples as we compare some things about stuff that doesn't seem to be related at all. So what's no association? Well, that would mean that neither variable has a clear increasing or decreasing pattern. Nothing's moving together, nothing's moving opposite. There's just no overall pattern at all. So what would that look like in an actual scatter plot? Well, if I have my x-axis and my y-axis here, to show no association, I could have a dot down here, but I might also have a dot up here. And then I might have all these dots kind of going all the way across here, but there is no clear increasing or decreasing pattern at all. Those plots truly are just scattered all over the place. So these are your three options. Once you create a scatter plot, which we'll learn a little bit more about next video, the details of that, but once you create a scatter plot, the thing that's so useful about it is then it shows you those two variables that you're comparing, is there any association between them? So let's just try really quickly before looking at some more scatter plots. Let's just try looking at two variables. If I give you two variables, can you tell me what you would expect to see? Would you expect them both to move together? Would you expect them to move in opposite directions? Or would you expect there to be no overall pattern at all? Let's look at these examples here and see what we think. So oftentimes it helps me. It says describe which type of association, so we know there's three of them, positive, negative, or none. Which type of association would you expect to see if you made a scatter plot with these two variables? So for example, here's variable one, a person's shoe size. That would be numerical, right? I could ask you what shoe size you have, numerical. And a person's height, again, that would be numerical. So oftentimes what I like to think of, first I think, is there an association? Would those two things be connected at all? And sometimes as you're growing, these things are a little wonky, but for most adults, if you ask them, here's what I like to think. I like to draw little arrows. What would happen as this increased? What would happen to this one? Anything? If you have a larger shoe size, in general, what does that mean about your height? Well, if you think basketball players, they're really tall. They also have huge shoes. Okay, so as your shoe size increases in general, so does your height. Those things often work in a ratio. And the other way is really true too. If you're really, really short, you usually have really small feet. So those are increasing together or decreasing together. The point is they're moving in the same direction, so that's what we call positive association. As one increases, so does the other one. And if I gathered a whole bunch of data about people's shoe sizes, paired up with their height, I could put it in a table, I could plot it on the coordinate plane, and I would see a general upward trend, shoe size and height. Okay, let's look at the next one. What about a person's shoe size and a person's GPA? Let me ask this. What happens as your shoe size increases? What happens to your GPA? Is it like the bigger your shoes are, the higher your grades? GPA is grade point average for grades. Or the bigger your shoes, do your grades go down? Or does the size of your shoes have no impact whatsoever on your GPA, right? There's all kinds of other variables. But I would guess for this one, if we compared those two, we'd just have dots all over the place because there would be no clear association between your shoe size and your grades. Okay, what about number 6? What about a student's number of absences? So let's think about this. If your absences increase, meaning you're gone from school a lot, okay, in a normal scenario, or in this scenario, it would mean you're not getting online and you're not watching the videos. So as your students, what would happen as the absences go up? Is that going to affect your GPA? If your absences go up, does your GPA go up? Does your GPA go down? Or does your GPA not change at all? Well, I can tell you from my experience as a teacher, as your absences go up, your GPA goes down, at least until you get things made up. And 1 or 2 absences, you're okay, but as they start to build, your grade really drops. So this is that opposite scenario. As one is increasing, the other variable is decreasing, so that's what we call negative association. If we plotted that on a scatter plot, we would see a general downward trend. Okay, one more here. The amount of time spent practicing a song. So there's one variable, time spent practicing. Let's imagine that one goes up. I always just imagine the first one increasing and then think about what would happen. So if I practice more, what happens to the number of mistakes I make? Well, the more I practice, my mistakes should go down. That's the idea, right? So that's a negative association. As one goes up, the other goes down. Okay, and then the only other thing you have to be able to do today is you have to be able to understand just these 3 key things today: positive association, negative association, no association. What is a scatter plot and how does it show us these things? And then the back side of your notes and your MLE, it's going to practice this idea if I just give you 2 variables, and it's going to practice this idea if I actually give you some scatter plots. So let's read the instructions up here. It says, for each scatter plot shown, write a sentence in this format. Okay, so you're going to fill in the blanks where the parentheses are. So you're supposed to tell me you're either going to say a positive. So here are your options. You'll say there is a positive association, or you'll say there is a negative association, or you'll say there is no association. And then you will also tell me between what variables. Well, how are you going to know the variables? If the scatter plot is made and if the scatter plot is done well, all of that should be labeled on it. For example, right down here on number 8, look at this. This is the x-axis. They've labeled it with numbers and they've also labeled it with words. The x-axis shows me the distance from the center of the city in miles. And then the y-axis tells me the rent in dollars. So this is comparing how far people live from the center of the city comparing to how much they pay in rent. I definitely see in this scatter plot a general downward trend. So that tells me negative association, and now I just have to fill in my variables. So here they are labeled, and then you try to make it like grammatically correct, okay? So here's what I wrote, and you can take a second and write this down. It says there is a negative association, there's the first blank. I can see that clearly because it's like a negative slope. There is a negative association between the distance you live from the city and the cost of your rent. That means if you think of like downtown Salt Lake, the closer you are to living in downtown Salt Lake, that means as your distance from the city gets bigger, you get farther away, what happens to your rent? Your rent gets cheaper. This also means the opposite direction. If you get closer to the center of the city, your rent gets more expensive. It just costs more to live right within a city. I don't know why, it's just the way it is. You can walk everywhere. People feel like they're in the center of things. I don't know. So the farther you are away from the center of a given big city, the cheaper your rent gets. As one goes up, distance, the other goes down, cost of rent. That's a negative association. All right, let's look at number 9. Check out these variables right here. I see on the x-axis, they've got hours of sleep. And on the y-axis, they've got test score. And I can see from the scatter plot, I don't even have to guess what's going to happen. I can see very clearly from this scatter plot a clear general upward positive trend. Okay, so I'm ready to write my sentence. There is a positive association between the hours of sleep you get and your test score. That means the more sleep you get, the better you do on your test. That makes a lot of sense. That also means it works the other way. The less sleep you get, the worse you do on your test. Sleep, oh my gosh, there's so much research into how sleep affects your brain and your well-being and how you feel. Make sure you're getting enough sleep. Okay, last couple, let's give these a try. If I tried to draw my yellow line here, would it go up? Would it go down? I don't clearly see any of those. So what that tells me is that this is a no association situation. Now, these little words are tiny. So this actual purple dot right here gives me a title. It's just telling me what each of those dots are. So on the x-axis, see that little word right there? It says age. So this is age in years. And I see this goes from 28 to 40. So it's not a representation of everyone. This study was apparently from 28 to 40-year-olds. It could change, and scatter plots are really interesting depending on how, if you narrow it or not, because this might change if you went all the way up to 80-year-olds or all the way down to 12-year-olds, probably change. But this was comparing from 28 to 40-year-olds. And this over here, if you can't read that, it says internet usage in hours per week. So for example, this dot right here is a 34-year-old that spent 18 hours on the internet over an entire week. Okay, this was also a 30, is that 36, 30, no, that's 38, 38-year-old who also spent 18 hours. So what I see from the data they've gathered, at least from 28 to 40-year-olds, I see no association between the age and the hours of internet usage. Again, do you think this would look different if I went like way down to 2-year-olds? Would that change things? Probably, but this data was only from 28 to 40-year-olds. Likewise, this particular scatter plot also has only a specific range. Again, the x-axis says age, but it's only from 16 to 25-year-olds. And part of the reason this one starts at 16-year-olds is because this y-axis says accidents per 100 drivers. So this data only applies to drivers. And it stops at 25 because that's apparently the data they were interested in, but that obviously people older than 25 drive. So I see a very clear downward trend here. So what that tells me is there is a negative association between age in years, at least between 16 and 25, age in years and the number of car accidents. That means the older you get, the fewer accidents you're in, probably just because you get more experience in driving. Now, again, I might argue that if we extended this, it'd probably keep a negative association for a while, but if we extend it all the way to older people, some of them get in more accidents because they can't see anymore and stuff. Anyway, so for this particular age group, there is a negative association, meaning the older you are, the fewer accidents you're in. All right, so for today's stuff, you need to understand what a scatter plot is, what it's showing you, and you need to understand when it is positive, negative, or no association and how to write that out. Give the MLE a try. If you have any questions, of course, email me, and you got this. You're doing great.